this regular expression matching problem. It's currently 168 people are online solving this particular problem. Quite interesting. So this is one of the problem which I often see get asked in interviews, and it is tagged as a hard on Leetcode. Of course, it is hard. It has a few edge cases. It has the solution is something that takes time to come up with. If you are reading this problem for the very first time, I think I've solved this problem a long time ago, maybe 5-6 years, 7 years ago, but let's try to solve this again today with you guys. So I'll just read the problem statement, then the constraints, and we'll try to come up with a solution. Yeah, let's start. Given an input string S and a pattern P, implement regular expression matching with support for dot and star, where dot matches any single character, star matches 0 or more of the preceding element. The matching should cover the entire input string, not partial. Makes sense? So one of the input, AA, and P is your pattern. Of course, there is no match, there is no star, or there is no dot, but we have length is not equal, so of course it would be false. It does not match A. For this one, we can take the first A as this, and then the star we can replace with another A. So yeah, there is a solution. So we just have to return true and false. For this one, so one of the character repeats multiple times, and what the dot means is any character. So dot star means that you can, so dot star means 0 or more star of any character, right? So this dot star is basically, you can think of it as a dot star, right? We can convert it to of one dot and then dot star, because star means like this particular character can come 0 or any number of times. So I put it one time here, and then I put it this again, and again I can do it like dot and dot, right? And I can say that star is just putting one character, and then we are not using star anymore. So now you can replace star dot with A and another dot with B. So that's why it is a match. Length of the string less than or equal to 20 for both the pattern and the string, which is which you can think of like you can come up with the n square solution, and this should be still fine within the constraint. S contains, I'm not sure if n square is the optimal solution, but let's see. B contains, S contains only lowercase English letters, P contains only lowercase English letters, dot and star. It is guaranteed for each appearance of the character star, there will be a previous valid character to match. What is this statement? Let's try to read this again. It is guaranteed for each appearance of the character star, there will be a previous valid character to match. Okay, so what it is saying is basically if you have a star, there will be some valid character here, something like S, like a dot, right? Something will be there, some valid character to match. So it won't be like this. Cool, then let's try to come up with a solution. So one of the things I can think of is, if I'm trying to match, let's say A, B, C, T is my this, and then I have dot star, right? So let's try to make it a bit like this. Or how about this? You do a B star, then you do a C, and then you do a dot star. So one of the things we can think of is like if we match, if we go and check for the first character of this string and the first character of this, if both of them are equal, right? If both of them are equal, then we just, there is like, we just have to check for the next character onwards for this and next character onwards for this. Very simple. But if after A we have a star, then that means A may or may not appear any number of time. So we may use A or we may not use A. And there could be a possibility that not using A gives you a result, but using A does not give you. Like if you use the A, you may not have a solution at all. So for example, let's take one case where you have A and A, then you have A star, and then you have a A. Yeah, let's take this example. Right now, what does this mean? So if we take this example, forget about the previous one, we'll come back to that. Let's take this guy for example. If I compare the first and first character and both are A, I would say that let's start with I equals to 1 now, I equals to 0 and J equals to 0. But now since I and J are matching, let's go to I plus plus, so I becomes your 1 and your J becomes also 1. Not 1, but you see there is a star, so you replace it with that. Now your J becomes 2. Now the point is, what is left is your string is A and your pattern is AA. Now there is obviously no match, right? So you don't have a solution if you use this particular A. So in this particular case, the right way would be to not use the first A. So it's basically that you replace this guy star with a 0 occurrences, then you have AA and AA to match, which is an exact match, and you have a solution. So whenever you see the first character is matching, if after the first character there is a star, that means you should also consider the option of not taking the particular element any number of times. But if that there is no star after it, that means you have to take that, you have to match those first characters. There is no other way. If that doesn't match, then there is no solution at all, right? So that gives us an idea, an approach that we can think of, is that I match the first character, and there are two things that comes to mind. So when I'm comparing the first character and first character, if there is no star after this, that means the first character has to match. There is no other option. So if it doesn't match, we just return false. There is no solution that is going to exist now. But if it matches, then I'm talking about the case where there is no star after the first character. If it matches, then we will go to the second character of this as well as second character of this and do the same thing henceforward, right? So basically solve the problem for the remaining strings. So remaining string would be what? Like it would be B C D, and here it would be B star C dot star, right? Just in case it was E, then simply there is no solution. You don't have any way to skip the first character because there is no star after it. You have to take it, and that's where there is no solution. So in this case, there is a match. There is no star after it. So we do have we have to take A, and we should take it. So we go and proceed for the remaining string, which is this. So your I becomes 1 and J becomes 1. Now you are at the second index, right? Considering the 0-base indexing, you started with I0, J0, and now I1, J1. Now here comes the second part. Now the first character of this string and this string is equal, but there is a star after this. So here comes the interesting part, which I was talking about. Either you take B, but you also have an option to not take B. That may give you a actual result. So let's start with that. So we took B, right? So we now have CD, and one case is that you took B and exactly 1 times and exhausted it. So now you start with C dot star. The other case is, I will just remove this guy. The other case is that you don't take B, right? There is a case that you don't take B at all. So you don't take B. So you are at B, C, D and C dot star. The third case is that you take B and you take one B, but you still keep the option to take multiple other B's, right, later on. So you come back to CD, and then you take one B. So you remove the first B because you matched it, but you still have the B star and C dot star, because B star means you can take B any number of times. So I just want to keep my option, right? So the basically you are breaking down that this guy into these three options, these three choices you have for this particular case. Now you can write a recursive solution, a backtrack solution, check all the possible ways and say if I have a solution or not, which would not be very optimal solution, right? Because as you can see, if you know that from this particular index and from this particular index, if I've evaluated certain possibility, I don't need to evaluate it again. There is no need. We can save that result. How you came to this point doesn't matter. How you can reach this particular stage, but if you reach this particular stage, then whatever happens after this, you can save it and use it for subsequent cases. So this hints us towards dynamic programming approach of solving this thing by memoization, and basically you kind of save for each I and j whether there is a possibility or not, and if you reach that, you just use the pre-calculated results. So that basically becomes and square solution, and come to the part where it comes in square. But now you can see like the problem has become fairly simple, but there are a few corner cases, of course. So when you have a star, there has to be a character before it. So you just have to consider that you are not taking just a star as a input, or you're not just considering a star, but you're also considering a star with a character there. So basically if like, let's think of in this way. If it is a very simple way of solving this problem is that you iterate from you just assume there is just one character in your input and there is just one character in your pattern, and those are the, let's say, last character of both the strings, right? Then you solve the problem for that, all the possibilities. Then you add one more character to your input, then you check that, keep on adding. So basically for the entire input string you have first checked for just one character of pattern, can we match it, and then you keep on doing this, increase the length of pattern, increase the length of s in a nested for loop, and then finally your solution will lie on if you had the full length of s and full length of p where there was a possibility or not. So the only thing that, like, this becomes a fairly simple 2D DP problem. In fact, it's just a 1D DP problem if I think of. But the problem is this part, that when you are considering a certain state, you have to consider the character with the star and not just this. So the problem is trickier because of this star and dot thing that we have to consider at each stage. How do I implement it? One more important thing is that if you have a dot and b, it should be b and dot. B matches any single character or dot b. So b, this dot you can only replace with one character. You can't replace it with c first and d and other things, right? It's just one character. But if there is a dot and then star, then you can replace it with any number of characters. It can become like any string. Basically dot star is any fucking thing, anything that you want, because you can expand to dot star, dot star, and then each dot can be any character. So this thing we have to keep in mind. Now let's organize our thoughts and see how we can code it with these corner cases in mind. I'm thinking that I don't want to go into handling these dirty code and make my code dirty by handling the small cases here and there. So I'm just trying to simplify. If I break down my pattern into a string with just the characters, and then the star part, I can put it as an identifier that this particular character can repeat any number of times. That would become fairly simple for me. Yeah, so I will shrink my pattern first to a simple string of characters, and I will remove the star out of it, and I will store the information that how many times a particular character can repeat. So for example, for this particular pattern, I will transform my pattern into this. I will write it as a b c dot. Right, there are 4 characters, and then a can happen exactly one time, b can happen maximum infinite time, right? So 0 means exactly once and 1 means infinity. Then you have c coming exactly one time, then you have dot coming infinite number of times, right? Yeah, now you don't have to deal with star, so your pattern becomes very simple. You just have to think of how many times a character can appear. So 1 means like that character can occur any number of time. If it was like dot and then dot star, that would mean we have 2 dots here, and 1 dot will appear exactly one time, the other dot will appear infinite number of times. So now my string becomes very simple, the pattern becomes very simple. I have stored the occurrences of it, maximum occurrences, and this. So and whether it is infinitely appearing, possibility of appearing it infinite number of times, or whether it is just one time. So I don't have to deal with star anymore. That becomes simpler. So the handling the corner cases and all those dirty coding and all that we may land into, we don't have to do it now. So so I would type a struct. Let's start coding. So I type a pattern, right, and which has a there's no character involved, so which has a string string a, and then it has a infinite boolean. Now this, in Golang, you can, instead of character, you can take a reun, which is just like a byte, and we can use that to match it. So reun and infinite, whether this is infinite or not. So I would say transform pattern p. This would give me a this will give me a transform pattern, which would be an array of this. So I would write this function now, transform pattern. This would simplify things a bit. So transform pattern would become p of string, and what it returns is an array of pattern. So now how do we do this? So we create an transform pattern array with a size 0, of course. Then we go and start with the iterating the p pattern. So if I plus 1 is less than p and p of I plus 1 equals to star, that means ith character is going to appear any number of times. So I'm going to put this tp equals to append tp. I will put a pattern and that will contain a reunion of p of I, and it will have infinite as 2 and a as I would say char as reunion of pi, and infinite equals to true, right? Then what I need to do is I need to do I plus plus here as well, so that we don't go over a star. Then what else? If it is not the case, then it's basically if the next guy is not star, then this guy is going to appear exactly once. So it will be this will remain false. The default is false, but just for clarity write it here. And then when I want to increase the I will increase automatically next time, so for the next character. So that is it. Then we just need to return the tp. So this is our transform pattern. This simplifies our problems now. tp, right? Now transform pattern we have. Let's now prepare a dp level. So for each I we need to know which j. I initially will take 2D array. We'll think of optimization. I don't think we need to, actually the size is very small, but we'll come to the optimization part as well. I think we don't need to have more than 2. Well, let's more than 2 for the nth input length. We just need to look at the next guy, so it should be fine. But let's move on to simplicity for now. Let's take this. I'll take this as let's define length right now. Your n equals to length of s and m equals to length of tp. Note here, it's not pattern p but tp, transform pattern. So we first take the size as n plus 1. Just for the corner cases, so that we don't exceed the array size. Now there is no way to initialize it in a simpler way in Golang, so I would do length of in fact n equals to n I plus plus. I would do dp of I equals to make it, and that would be m plus 1. So that is now. And why do I need to take this as an integer? I think boolean should be fine. So dp of I equals to m plus 1. Now the thing is that whenever we reach n and m, the last, like if we have exhausted the entire input string, we have also exhausted the entire pattern, then we have a solution. So that's why I took this as a plus 1 size here, so that we don't have to go into dirty size checking and if else, lot of else in the code. Let's solve this now. So we start with the very last guy and we keep on adding guys in from the input. So we're just solving for the one length input first. Then we do the same for the pattern. And finally our solution would be whether we have a solution if we start with the first character and of input and first character of pattern. Cool. So coming to here, if the TP of j dot infinite is not true, it is not true, then if just give me a second. Yeah, so if it is not infinite, right, if you don't have an infinite supply of this particular character, then it has to match, so TP of I and j will be, if TP of j dot char equals reun of s of I. If it is equal, that is first condition, it has to be equal, and TP of I plus 1, we go for the next character, we go for the next character in the pattern as well. Those also has to have a solution. If only they have a solution and these guys are equal, then only we are going to have a solution for dp of I of j, because there is no infinite supply. If there is an infinite supply, then we may or may not take it. So your dp of ij becomes, you first take it, you first take the first character if those are equal, and then you check for the next character, or you don't take it. So what are the possibilities? First is take it completely, exhaust the pattern completely, so exhaust the pattern completely, just take one occurrence, ignore. These are the three cases, right? So if we have to exhaust the pattern completely, both of them should be equal, and if both of them are equal, then we exhaust it completely, so we go to j plus 1 and I plus 1, so that is one possible solution, right? Once you have that, the next guy is just take once, so I will just put it here, exhaust the pattern completely. Now we have to just take one, so we take one occurrence and we proceed, so that would become dp of I of j. Remember, we have to take the OR here, so the thing is, we have to take OR, so it's not like we are going to any one of those possible solution has a solution, we are going to so I will write it like this. So case 1, let's take case 2. Case 2 would be that you take it only once, so but you leave the pattern for remaining things. So for that also, these two characters has to match, and when you are checking for the next input, we are not exhausting this pattern, so you continue with the j itself. The third case is that you completely exhaust the pattern, and you ignore the pattern, in which case you don't have to worry about whether the characters are equal or not, so it just becomes your dp of I plus 1, not I plus 1. You have not consumed the I part, the input path in this case, because you have ignored, so you are just going for j plus 1. you are ignoring this particular pattern at all. So that becomes you start with I and start matching with j plus 1. This should solve. Now we have completely not considered the dot part yet. We are only talking about start part. We'll come to that. For TP of I of j equals to case 1 or case 2 or case 3, right? Any of these is true, we have a solution. Now where do we need to take the dot part? Wherever we are doing a string matching, the string matching does not need to be exact if the character is dot. And that's where I think we can write a function and call it r equal, which takes a rune A and rune B. Think of it like just a character in your language, and if A equals to B, it returns true, of course. But if B equals dot, it returns true, else it returns false. So when we are checking these two guys, we can call this function every time. Yeah. So I will just replace it, put the here, put the here. Now I think this should be fine. So equal cases are considered. Let's just, I think this should work. Let's just read through our code again, just so that we haven't missed anything. Yeah, let's just go and read. So first of all is we are transforming the pattern. So we took P as a, and we are returning an array of patterns. So we created an empty array, we iterated over the length of P. If I plus 1 is less than length of P, and then P of I plus 1 is equals to star. That means we are appending this character and we are setting infinite as true. We are increasing the I so that star is skipped for the next time. We check the real characters. Else we come here. If there is no star after it, this character has to appear exactly once. So we take it and insert it, and then we return it. R equal, comparing both. If both of them are equal, true. Else if B is dot, then it can match this, so true. Else it is false. Coming to is match. Transform the pattern TP, n equals to length of S, m equals to length of TP. DP becomes your boolean 2D DP n plus 1, m plus 1. And if you exhaust both of them, you are going to get a solution. So true. I equals to n minus 1, I greater than 0, I minus minus, j minus 1, j greater than 0, j minus minus. If TP of j was infinite, if this particular pattern has infinite appearances, then if the character at this is equal to character at input, then if there is not an infinite, then this has to match. So only if they are matching and we have a solution for the next inputs, characters and the next patterns, which is I plus 1 and then j plus 1, because these are not infinite in supply, then only we are having a solution. Else we go to the part where we can have an infinite possible occurrences of this particular pattern P pattern. So exhaust the pattern completely. So for that it has to be equal first, and then we go to the next input character and the next pattern character. Just take one occurrence of this, so we preserve the pattern, but just to take one also it has to be equal, and then we proceed with the next input, but we preserve the pattern. So j, it's not j plus 1. We ignore the pattern at all. We didn't take it. We didn't take any instances of it, but we left it for the next guy. So we didn't left for the next guy. This is the case where we didn't take it. Now we want to compare with the next pattern because there was possibility 0. So I would just write it just 0 times. So you still have the input to match, but with the remaining pattern. Now there may be one more case where you don't take this guy. If you don't take this guy, your input has to match with something. So either take it or not, or you completely exhaust it. I don't think there is other way. Yeah, I think these are the possible cases. So your final answer would be if there is a possibility in any of these ways. So case 1, case 2, case 3. I think this should work, hopefully. There may be a few compilation errors and all. Let's check. Let's run. As expected, there is some compilation error at line number 1. And as dumb as I am, it was totally expected. Okay, I've done I've done a bit of coding in Golang, but still do these silly mistakes. Usually I use ID and all for this. I think these are some stupid compilation errors. Undefined A because it should be like this, not this. I keep switching between C, C++, Java and Golang, and that's why I get into these kind of errors. Perfect. So we have a lot of wrong answers. This guy is saying true, false, and this is false. We have true. It's not that our answer is always returning false. It's also returning true sometimes, which is fine, but for this case we said it's false. Now this is very interesting case. This should have worked ideally. Let's see what we did. So I think we should have dry run for this. This is a kind of a very important case for this. Anyway, so let's see where does the problem in our code. So dot star is not matching. So we are saying false, but actually the answer should be true. So I'm not sure how do we fold it here. So why did this happen? So if you have dot star, our pattern, how it look like? So you go to iterate through P, and if your next character is star, then you append this and this multiple times. So you have the pattern should be like your first character appearing any number of times. Now you go and match this. So if it is an infinite supply, just have to be equal. I think this R equal is not working correctly. I feel if B equals to dot, I think this part is something is wrong here. It has to be volume of this, I believe. If it is equal to this, then it is true. No, it is still giving the wrong answer. So if it is B is equals to, then it's basically true. Let's see what is B. Oh, I see what happened here. We did this other way around. I think it should be A ideally, because we are first passing the pattern and then passing the input. Yeah. So this was the pre-show. I think even if you remove the rune, this should work, because this is automatically converting into rune. The only advantage that is give you if your machine is like you have 2 bytes for each character, this would fail. So it's better to convert it into rune so that it is uniform and then run it. Okay, there might be a lot of edge cases. Can we think of anything? So sample test cases are passing, but there could be edge cases. So let's think of. And before that, what is the time complexity? Is 1 square, of course. and 1 square in space. As you can see, we can optimize because we are only taking I plus 1 for this guy. So if we only store the next guy DP answer, we should be fine. We don't need to store all the guys here. So this 2D array could be just simply 1D array, and you can just, we'll do that optimization as well. I think it's fairly small. It won't put much effect given the problem statement constants are very less, but we'll still do it for the learning purpose. What are the corner cases I can think of? So star will always come when there is a character. That's the input guaranteeing you that this will happen. It says here that it is guaranteed each star will appear after a character, valid character. I think this should work. Not able to think of, do we have, what is the length of the string set? Can we have a pattern? So at least one pattern and one length input is there. So let's just submit this now. Oh, we have a wrong answer. Interesting. Where did we go wrong? So we have A and pattern is AB star. We say false, but it is true, which is fine because B may not appear any number of times. B may appear just 0 number of times. So we should still, this should be true. I think there is some bug in our code. Our approach is still right because we are considering the case where we take it 0 times. So we have, so we took I first because this is matching. Oh, I see what happened. Our input got exhausted, and I think these are the edge cases. Since your input got exhausted, you still have pattern B to match. And if your pattern B got exhausted, you still have pattern A to match. So these are the edge cases that we have to consider. Interesting. Let's think of it. Think of this edge case. I will be back in a minute. So, sorry for the noise. Yeah, so we have few cases not covered yet. Let's take this where we have either of these guys getting exhausted, like either of these guys' length is completely done. We are out of the loop. What do we do in that case? So let's take a case where we have I exhausted and B is still there, B pattern is still there. Then we have to match that case. In that case, the entire remaining pattern should be evaluated to empty. So So these are the cases when we are saying we go I plus 1 and we go j plus 1. Whenever we are saying this, the I plus 1 may be the last character and j plus 1 may not be the last character. So that is that case. The other case is that you have pattern getting exhausted, but you have all other characters inputs to match. If that is the case, then input is still there but your pattern has got exhausted, then there is no solution. You have to have some pattern to match to. Input is not optional, so all the characters in input that are left has to be matched, but you are not left with any pattern, so there won't be any solution. So that case is fine. We just have to, and that case would be basically your I having n and all the other m's apart from just m, so 0 to m minus 1, for which the solution would be of course false, so that is fine. But for all the other cases where you are I has, oh no, let's get back. So your I is still somewhere less than n, but you have reached m, you have exhausted all the pattern, so that particular case would be false because we didn't set it for any other character. So for all n 0 to n minus 1, if we reach m, it would be false, and which makes sense because we have exhausted the pattern, we still have the input. But for all the cases where we still have pattern but we don't have any n, any input, then it's not always false. There's one case where the remaining pattern evaluates to an empty string, we have a solution. So just that particular counter case we have to handle. How do we handle that? So if we are saying this, then if we make this a function, we would just reevaluate that part. Or there is a way to do this, that we check for each character, for I equals to n, for you check for each character whether they evaluate to empty string. And the only way a pattern would evaluate to remaining pattern would evaluate to an empty string is when all of them evaluate to empty string. So it's basically for j equals to m minus, so we haven't exhausted pattern, so dp of n of j, we have exhausted the input, is if you can make if dp of j dot infinite and then dp of n of j plus 1. And j plus 1 should be handled here. This should be true for the last character, but only if the last character is infinite. Yeah, I think we are saying true now. So yeah, this solved it. So just one for loop where we take care of this particular corner case, which is that if your input had exhausted, the remaining patterns should evaluate to empty string, which is only possible if it has a 0 to infinite supply of each character and the next guy also becomes empty. So in this case should be g plus 1. Go to next, and this is the same thing. So let's try to submit this now. Hopefully we took care of this case. Yep, we did. So cool. So we have 0 milliseconds beats 100%. Oh really? I thought n square is not that optimal. Cool. We also took some space, which is fine. Additional space we took. We don't have to, but it's fine. I think this solution fairly works for the given constraint.